Good evening, students.
Good evening, sir.
Good evening, beta. So basically, next is production of. So in the last class, I was discussing Nicole Prill. Now, next is production of elliptically polarized light. I'm writing EPL. Production of EPL. EPL means elliptically polarized light, and and CPL, circularly polarized light from plane polarized light. So if you are having plane polarized light, then from this plane polarized light, you want to produce EPL and CPL. EPL means elliptically polarized light and CPL means circularly polarized light. This is our objective. So this is our objective. So how can we produce it? How can we produce it? So try to understand. If you are having this calcite crystal, ठीक है, this is a calcite crystal like this. This is the front face of the calcite crystal. ठीक है ना, this is the front face of the calcite crystal. ठीक है, behind it there is a thickness T, so it will be something like this. In the background it will be like this. ठीक है, it is going to be like this. So you are having this type of calcite crystal. T is the length or thickness, you can say, of this crystal. Suppose T is the thickness like this. ठीक है, and this is the front side. This is the front side. This is the other side, back side of it. Now you have cut this calcite crystal in such a way that this axis, this is suppose x-axis, I call it as x-axis, and this x-axis is the optic axis of this calcite crystal. So we cut this calcite crystal in this structure with its optic axis parallel to this face, and it is along the x-axis. This is y-axis here. It will be y-axis like this, and this light is propagating and it will be like this. So this is z-axis here. If you look at this will be z-axis, you can see. It will be like this. So try to understand. So what is happening? You are having this type of calcite crystal. What is this? This is calcite crystal. Calcite crystal. And light is incident on it. A plane polarized light is incident on its face. Light is propagating along this line. So along this line, light is propagating. So this is the line along which light is propagating. ठीक है? So here this is incident. So a plane polarized light whose electric vector is like this. ठीक है? So you are having a plane polarized light whose electric vector is this. You can call it as E naught. E naught. E naught. This is the incident plane polarized light that is hitting it, and this light is propagating along this direction. This is the direction in which light is propagating. So try to understand like this. Your electric vector E vector is E naught. E naught. ठीक है, this is the direction of E naught, and this will be, you can say, sine of omega t minus kz. It is like this. It is like this. I'm saying this is Z equal to 0. I say Z equal to 0. So electric vector here, when it is hitting this will be E naught and sine of omega t. So this is the incident plane polarized light that is falling here on this surface, and this is the direction of the electric vector. So electric vector is confined along this line. There is a plane that is passing through this red line. This is the direction of propagation, and electric vector is like this. And electric vector is like this. So if this is electric vector, so it will be like this. Try to understand this type of plane of vibration will be there. So electric vectors are like this, and here it is propagating in this direction. It is propagating in this direction. So this will be the plane of vibration. This will be the plane of vibration for this plane polarized light. Now you can resolve this E naught into two component. One component of this electric vector will be parallel to this component. So this component, this will be equal to, you can say this will be E naught. What it will be? This will be E naught. I say this is cos of theta. Okay, you say that this angle is supposed theta. If you assume this angle as theta, then this will be E naught cos theta. And this component here, this will be E naught sin theta. So this incident electric vector of the incident plane polarized light, you can split this vector, you can resolve this electric vector in two component, one parallel to the x-axis. X-axis is the direction of optic axis. In this direction, you are having optic axis, and this axis is perpendicular to the optic axis. This axis is perpendicular to the optic axis. Okay, try to understand. Now, I can write this E vector. This is incident vector, incident plane polarized light. I can write it as this is E naught x component. This will be I cap plus E naught y. This will be j cap and multiplied by sine of omega t. Sine of omega t. So this is incident plane polarized light. This is incident plane polarized light. Plane polarized light. Okay. Now what is E naught x? E naught x is E naught cos of theta, and E naught y, that is E naught sin theta. So this is what? This is incident plane polarized light. This is incident plane polarized light. So this light is incident over here. So whenever a plane polarized light is incident, that plane polarized light you can write like this. Why this is plane polarized light? Try to understand. If you divide these two equations directly, you can observe why this is plane polarized light. If you divide this equation, these two equations, then you will find out that E naught y upon E naught x, that is tan theta. So E naught y is tan theta and E naught x. So if you plot E naught x and E naught y, try to understand. If this is x direction, this is y direction, then if this is E naught x and this is E naught y, then resultant, that will be this one. So this is the line. ठीक है ना? This line, this is making a slope of theta. ठीक है? Here it is making an angle theta with E naught x. So basically this line is representing this electric vector. This electric vector is represented by this line. ठीक है ना? It is represented by this line, and this is plane polarized light. So what is the correlation between E naught x and E naught y? If you plot E naught x as a function of E naught y, then you will find out it will be like this. So this is the incident plane polarized light. Its amplitude is E naught. So this type of plane polarized light is incident over it. Now this is a doubly refracting crystal. What type of crystal is this? This is calcite crystal, which is doubly refracting medium. ठीक है ना? What is this? This is doubly reflecting medium. Reflecting medium. This is doubly reflecting medium. So basically here, when this plane polarized light is incident over it, then you will find out it will split into two components. It is going to split into two components. One component will be, बोलो बेटा, one component will be ordinary ray or ordinary light, another will be extraordinary light.
Extraordinary.
ठीक है? So out of these two, which one will be extraordinary light, which will be ordinary light? So
Sir,
you are aware.
perpendicular will be extraordinary light.
Very correct, beta. So this component electric vector which is parallel to the optic axis, because optic axis will lie in the principal section. So try to understand the component which is parallel to optic axis, that will surely lie in the principal section. So this will be this E naught cos theta. This is going to act as E ray. So try to
Okay.
understand this one. This is going to act as E ray. This is going to act as O ray. So this one, lower one, Y component, that is going to act as ordinary light. Ordinary light. ठीक है? And this one, so this is ordinary light. If you look at this is extraordinary light. Extraordinary light. Inside the doubly refracting medium. ठीक है? So they are acting as E ray and O ray. So this component is acting as extraordinary light. This is acting as ordinary light. Try to understand. So when at z equal to 0, okay, so at z equal to 0, when this plane polarized light is incident, two different lights, okay, one ordinary light and another extraordinary light is created. So what will be this E ray? E ray will be, this will be E. Okay, you can say this as Ex, and this will be E naught x, E naught x sine of omega t. It will be like this. Okay, and Ey, that is going to act as O ray. It can be written as E naught y, and this will be sine omega t. Okay, now both these lights, O ray and E ray, they are going to travel along the, because suppose this is the plane surface. Try to understand, if light is incident normally, try to understand, if light is incident on this medium normally, then what will happen? This light will move, light will travel. ठीक है ना? Light is going to travel. ठीक है ना? Perpendicular to this angle of incidence here. What I am saying here, this is doubly refracting medium. This is air. So when this PPL is incident, ठीक है, PPL is incident at angle of incidence 0. So what will be the angle of refraction? Angle of refraction will be 0. So what I am here saying, I'm saying angle of incidence is 0. So that's why angle of refraction, that will be 0. So that's why for both ordinary ray as well as for extraordinary ray, both ordinary and for extraordinary, both angle of refraction will be 0. Yes, beta, please. Hello. So what I am saying here, this is doubly refracting medium. Light is incident normally on it. When light is incident normally, then here angle of incidence is 0. Angle of incidence is measured with respect to the normal. So it is incident light is falling along the normal. So angle between the normal and incident light is 0. So that's why angle of incidence is 0. So angle of refraction will be 0 for ordinary light and extraordinary light. So angle R is 0 for both. For both O ray and E ray. And E ray here. Why? ठीक है? Why they are traveling along the same line? They are traveling along the same line because light is incident normally. So there will be their angle of refraction will be 0. So they are going to travel like this. So both E ray and O ray. E ray is traveling in this direction, O ray is traveling in this direction. ठीक है? Both E ray and O ray, they are traveling in this direction. ठीक है ना? So both are traveling one after the another. ठीक है? So
Sir,
here, yes, beta, please tell me.
sir, can you once again explain why E naught x sin omega t is E ray? Means I can understood that with principal section.
Yes, beta. Tell me one thing. What is the definition of E ray? Just
Sir,
think about the definition of E ray. ठीक है? E ray के बारे में. So E ray is that plane polarized light whose electric vector will be parallel to the principal section. Will be parallel to the principal section. And what is principal section? Principal section is the plane which is parallel to the propagation direction of the light. ठीक है? और propagation direction of the incident light, and it also consists of, or it is parallel to the optic axis. So what you are saying that E ray is the ray whose electric vectors are parallel to the principal section. And suppose this is your principal section. Suppose this is your principal section. So, or this optic axis, this optic axis will always lie in the principal section. Okay? And what is happening here? Try to understand. One of the electric component, this is becoming parallel to the optic axis. So you are saying one component is parallel to the optic axis. So automatically this component will lie in the principal section. So this component, this electric component, electric field component is parallel to the optic axis. So automatically it will be parallel to the principal section. So that's why this component E naught x or E naught cos theta, ठीक है, E naught cos theta or E naught x, this is behaving as extraordinary light. This is behaving as extraordinary light, or in another way you can think how light is incident. Light is incident like this. So where is the principal section here? So principal section will consist of this axis and this propagation direction. So you can consider a plane that is consisting of this optic axis and this propagation direction. So this component electric vector is parallel to this plane. ठीक है ना? This is parallel to this plane. So this is going to behave like an extraordinary light and this is perpendicular to the principal section. So that's why this is going to behave as ordinary light. So this component is behaving as ordinary light. This component is behaving as extraordinary light. Is it okay here?
Yes, sir. Yes.
Now, so try to understand here because light is incident normally. So E ray and O ray both are traveling along the same line, one behind the another. So here, what can you observe? Both E ray and O ray. E ray and O ray are traveling along the same line, one behind the another, one behind the another. ठीक है ना, one behind the another. Now, can you tell me, will their speed will be same? You are going to tell me either their speed will be same or not. So what type of crystal is this? You are having quartz crystal. कौन सा crystal है? Calcite, sorry. This is a calcite crystal. Calcite crystal. And you are aware calcite crystal is a negative crystal. Negative crystal. ठीक है ना? This is a negative crystal. What is the meaning of negative crystal? Means where speed of the extraordinary light will be greater than speed of ordinary light. ठीक है ना? Speed of extraordinary light will be greater than speed of ordinary light. Is it clear?
Yes.
Sir.
Okay, beta. Here in this medium, beta, refractive index for E ray will be Ne, and refractive index for O ray, that will be No. ठीक है? There, this will be refractive. Ne is the refractive index for E ray, No is the refractive index of O ray. Now try to understand what will be the optical path that is traveled by ordinary light when it is emerging from here. So this light will emerge from here. Try to understand. So it is going to emerge from here. ठीक है ना? This light is going to emerge. Here you are having emerging light on this side. Emerging light will be here. So try to tell me one thing. How much optical path is traveled? This thickness of this crystal is T. So how much distance, optical path length, is traveled by the ordinary light, and how much distance is traveled by the extraordinary light? So optical path here, optical path traveled by O ray in crystal, inside the crystal, that is equal to optical path length. You can say this will be refractive index of the medium for O ray into distance traveled, that is T. This is the optical path traveled by the ordinary light. ठीक है? So this is, you can write XO. This is N naught T. By extraordinary light, how much optical path is traveled? That is Ne into T. That will be Ne into T. ठीक है? This is the optical path. So what is path difference between them? You can say delta. Path difference, that will be difference between these two. XC difference XO. ठीक है? XC minus XO. Whichever will be greater, that will be first. So here if V is greater, then automatically Ne will be lesser as compared to NO. So XO should be first, XC should be second. So what is the path difference? What will be the path difference? Path difference delta, that will be XO minus XC. ठीक है? This will be how much? This will be NO T minus NET. This will be NO minus NE into T. This is the path difference between O ray and E ray when they are emerging. So O ray and E ray, they are traveling along the same line, one behind the another. One is moving fast, another is moving slow. Who is moving fast here? Extraordinary light is moving fast. So optical path traveled by the extraordinary light will be different from the optical path that is traveled by the ordinary light. So when they will emerge, when O ray and E ray, they will emerge from the other side of the crystal, then there will be a phase difference or path difference between them. When they are emerging on the outer side, or at the other side where you can say Z equal to T, this will be the path difference between them. So what is the phase difference delta between O ray and E ray? That will be 2 pi by lambda into path difference. So delta is the phase difference between O ray and E ray when they are emerging from the other side. Try to understand. This will be NO minus NE into T. So what is this? This is the phase difference. So you can write delta is the phase difference between O ray and E ray when they are emerging from the other side of the crystal. So delta is the phase difference between O ray and E ray. O ray and E ray when they are emerging out, when they are emerging out from the crystal. This will be. So when they are emerging, this delta phase difference will appear in between them. Okay, na? This will be the phase difference that will emerge between them. So now on the emerging side, okay, so what will be emergent light from the crystal? Emergent light, yeah, transmitted light. Okay, na? You can also write it as emergent light or the transmitted light. ठीक है, कहाँ पे emerge कर रहा है? Where it is emerging at Z equal to T. So how much it will be? Try to understand. This will be E naught X, and this will be, this will be EX, not E naught X, just once. This will be EX. X component will be how much? This will be E naught X, you can say, sine of omega T plus delta beta. ठीक है? And what will be EY? EY, that will be E naught Y. This will be sine of omega T. So this will be the emergent light. Here, when EX and EY, they will be in the air. They will behave as ordinary light. Both E-ray, both E-ray and O-ray, they will start behaving as ordinary light. ठीक है ना, when they will emerge. But because they were traveling along the same line, so when they will emerge, what you are going to observe on the emergent side? Superposed behavior. ठीक है ना, both emergent light, they are going to show you the superposed behavior. This component of light and this component of light, they are going to superpose, and whatever will be the resultant light, that will be the superposed of these two components. So on the emergent side, I am having this one. Is it clear what I have written here? Hello?
Yes,
Sir,
Yes, sir.
depend on means the phase
Delta.
difference, right? Delta.
So if you can change delta, emergent light will be different. ठीक है? Try to understand. If you change delta, emergent light will become different. And on which factor this delta is depending? Delta is how much? Delta is 2 pi by lambda. This will be NO minus NE. That is okay. You cannot do anything with this part. So this delta is depending upon thickness. So if you are changing the thickness of this crystal, then emergent light will be different. ठीक है? So what can you do with the help of this crystal? What you are doing here, you are introducing with the help of the thickness or with the help of this crystal of length or thickness T, you are introducing a phase difference of delta between O ray and E ray. What actually we are doing in one line, if I want to say that here, when a plane polarized light is incident on a calcite crystal normally, then O ray and E ray are created, and by passing through this crystal, a phase difference of delta is introduced between O ray and E ray. And on the emergent side, you are having this light. Okay, you will have this light. Is it okay now?
सर
Yes, beta, please.
सर EY component में डेल्टा क्यों नहीं आया है sin
आ
omega t
सकता है
पे?
बेटा. This will be delta. You can write here minus delta here. It doesn't matter. ठीक है. If I
तो
bring
सर
here, this will become minus delta. So phase difference will be. You can write here delta also. You can
तो
write
सर
here
माइनस
omega
डेल्टा
t.
कैसे होगा?
Try to understand. You can also write like this. Later on, I will do this. What his question is? His question is quite good. Later on, we will deal with this aspect. He's saying, suppose I'm saying this is 30 degree. So
Yes
I'm
sir.
saying phase difference between these is 30 degree. So here this will be 30 degree. So I can write these equations like this. Try to understand. This will be omega t plus
Plus 30 degree.
30 degree.
Yes sir.
One way is to write like this. And another one, this will be E naught y sine omega t. So here phase difference is 30 degree. Another way to write this equation, this set of equation is this. I can write like this. Ex is equal to E naught x sine of omega t. And here I can write Ey, that is E naught y. This is sine of omega t minus 30 degrees. So both are same equation here. One thing is this, but his question is different. So if I'm writing like this, I can also introduce that minus delta here. But what his question is, he's saying that if you are having Ex is suppose E naught x sine of omega t, then Ey is, I write it as just E naught y, and this is sine of omega t plus 30 degree. ठीक है? Why I'm not writing like this? We can
Yes
write
sir.
like this because try to understand. If your equation is like this, ठीक है, suppose this is the situation, what is the value of delta here? Delta is 30 degree. And if your equation is like this, then automatically here, this equation can be written like this, but what will the value of delta here? That will be minus 30 degree. Both are same. Try to understand. So if I'm writing delta is minus 30, so when you will take this minus 30, okay, in y equation that will become plus 30. Is it okay what I'm saying? Hello?
Sir,
So it's
then EY it will be omega t plus 30 degree this side.
on this side, he's saying that why you are not introducing delta here. But there is no need to introduce delta. He's saying why I'm not writing that delta here with y. Because this delta is going to serve my purpose. Suppose your equation is like this. And you want to write this equation in this way. So what will be your equation? Just 1 second. What will be your equation? Your equation will come in this way. Ex is E naught x sine of omega t minus 30 degree. And Ey, this will be E naught y and sine of omega t. So basically here, if you are introducing delta here, it is going to serve this purpose as well as this purpose. It depends upon who is moving faster. Okay? So phase difference between these two is 30 degree or minus 30 degree.
Sir,
This
lagging behind.
yes, beta.
Lagging behind.
One is representing here. It is representing that this is moving ahead and this is lagging.
Yes sir.
And
समझ
here
गया.
in this case, this Ey, this is moving ahead and its phase is
यस
lagging.
सर, ये है लैगिंग कर रहा है EX
ठीक है ना? So
component.
this is the meaning of this. So this is our choice. Either we are introducing delta here or here. But in general, you introduce delta. In most of the books, you will find out they have introduced delta in the X component. But
X component,
there is
yes
no
sir.
rule. You can introduce in Y also.
यस सर. सर अगर
Okay.
Y में अगर हम अप्लाई कर रहे हैं तो EX वाला माइनस हो जाएगा.
बिल्कुल, that will be minus.
यस सर, समझ गया.
So what will be my emergent light? Where is my emergent light will be like this. ठीक है? So I am removing this. Thus. Now, this is the phase difference. So this is my emergent light. So what will be the emergent light? It will be plane polarized light, it is circularly polarized light, or it will be elliptically polarized light. What this light will be? Now question is, what is the nature of emergent light? So it may be plane polarized light, it may be circularly polarized light, or it may be elliptically polarized light. How I know this? For that purpose, this is emergent light. So here, this is emergent light. This is emergent light. Okay. Now, what I am doing, I can write this sine omega t from this. I can write sine of omega t as Ey upon E naught y. I'm just doing very simple algebra here. Actually, if you want to find out, this is elliptical, it is circular. ठीक है, what type of or elliptical, circular or plane polarized light, you have to find out the correlation between Ex and Ey component, and you have to eliminate this time. So if you want to find out the trajectory between Ex and Ey, then what you have to do, you have to eliminate this time. You want to correlate Ex and Ey with each other by eliminating this omega t. This is my purpose. Only then I can find out what this combinedly, what Ex and Ey together, what they are going to form on superposition. So that depends upon that. So I have to eliminate this omega t. So from here, from second equation, I write sine omega t is Ey by E naught y. From this equation, I can write Ex upon E naught x. That is equal to sine of omega t plus delta. So I write it as sine omega t cos delta plus cos omega t sine delta. Sine delta it will be. So in place of sine omega t, I can write Ey by E naught y. So I can write here Ey by E naught y cos delta. Here plus this sine delta will be as it is. And how can you write this cos omega t? Cos omega t will be equal to 1 minus sine square omega t. So this will I can write 1 minus, in place of sine omega t is this. So this will be Ey square divided by E naught y square. This will be. So this is my equation. Now I want to simplify it. So what you do, you want to eliminate this square root. So to make it simplified, so what I bring, what I do, I bring this first term on the right side to the left, and then I will make the square of it. So what it will be, Ex by Ex naught, Ex E naught x minus E naught y. This is cos delta. That will be sine delta here. And this will be square root of 1 minus EY square upon E naught Y square. Now make the square of both sides. Okay, so this will be, make the square of this, make the square of this. So first term on squaring, it will be EX square upon E naught X square. Here it will be plus EY square upon E naught Y square cos square delta. From this side on making a square, bring this term on this side. So this will be plus EY square by E naught Y square. E naught Y square, and this will be sine square delta. Sine square delta. Okay. Next term here, there will be a mixed term. Square of this is there, square of this. A mixed term will be here. Mixed term will be EX, EY divided by E naught X, E naught Y cos delta, and here this will be sine square delta. This will be. If you combine these two terms together, then this will be cos square delta plus sine square delta. That will be 1. Yes, beta, please.
Sir, 2, it will be
2 will be there. You are correct, beta. Here I should write 2. Okay, this will be 2. Correct, beta. So what it will be? This will be EX square upon E naught X square plus EY square upon E naught Y square minus 2 times EX EY upon E naught X. This will be E naught Y cos delta equal to sine square delta. ठीक है, for a particular thickness T, for the particular length of this crystal T, this delta will be constant. So for a particular T, this cos delta is a constant, sine square delta is a constant. So this is the profile of the emergent light. This is the correlation between EX and EY for the emergent light. ये, what is this equation representing? ये किसका equation है बेटा? This is a general equation of ellipse. If you look at this, this is a general equation of the ellipse. So this is a general equation of an ellipse. This is a general equation of the ellipse. So the meaning is, in general, on the emergent side or emerging light will be elliptically polarized light. So you can write here, it means in general, emergent light will be elliptically polarized light. It means in general, emergent light will be elliptically polarized light. ठीक है? Full stop. This equation depends upon delta. This equation depends upon delta. This equation depends upon delta, and for particular values of delta, this equation depends upon delta, and for particular values of delta, this equation may convert into a straight line. this equation may convert into an equation of a straight line. This equation may convert into modified into a equation of a straight line, comma, an ellipse or a circle or a circle or a circle. ठीक है? So you have to remember this equation. This is the general equation of electric field when it is emerging on the other side of this calcite crystal. ठीक है? So whatever is emerging on the other side of the calcite crystal, this will be the correlation between X component and Y component. And this correlation actually depends upon this delta. This correlation depends upon various values of delta. Now, different cases. Okay? Now here I will discuss, this is the most important part of the polarization. Now I will discuss various cases and you have to remember all these cases one by one. Okay? So in polarization, if you say that which is the most important part, this analytical part, you have to understand this analysis. Only then you can apply this to find out other features, other aspects of the plane polar, of other aspects of the polarization. So come back here. Now what is my equation? Equation is Ex square E naught x square plus Ey square E naught y square minus 2 times Ex Ey E naught x E naught y. What was this? This was cos delta equal to sin square delta. ठीक है? Is this your equation? This is your equation. Now, what is this representing? This is representing the emergent light. First case. Case 1. देखो बेटा. If thickness, please write here, if thickness T of the crystal, if thickness T of the crystal is such that, if thickness T of the crystal is such that the phase difference between, if the thickness of the crystal T, small t, is such that the phase difference between O ray and E ray, phase difference between O ray and E ray is delta equal to 0, 2 pi, 4 pi, 6 pi, like this. Okay, so what you are doing, you are choosing the thickness in such a way that delta is coming out to be either 0 or 2 pi or 4 pi, 6 pi, like this. Then what is going to happen for this delta, this sine delta will be 0. What will be sine delta? Sine delta will be 0. And this cos delta, this will be plus 1. And this cos delta, that will be plus 1. So what will be this equation modified? This will become 0 and this will be 1. So this equation will become
minus
Ex
2
upon
whole square.
whole square बन जाएगा. This will be Ex upon this. This will be Ey upon E naught y whole square of this, and that is 0. This will be, remove the square, you will have Ex upon E naught x. ठीक है, square is moved and bring this term to other side. So this will be Ey upon E naught y. So how can you write this? I can write this as Ey equal to E naught y by E naught x, and this will be Ex. What is E naught y, E naught x? You have already defined it. What is E naught x, E naught y? Where I have defined here. This is E
Sin
naught
omega
x,
t
this is
sir.
E naught y. So this will be tan theta.
Yes sir.
Okay. So E naught y by E naught x, E naught will cancel out sin theta upon cos theta. That will be tan theta. So this will be tan theta. So what will be Ey? Ey will be tan theta. And here this will be Ex. Now plot between Ex and Ey. Now if you draw a plot between Ex and Ey, this will be a straight line. So if you plot here, I'm plotting emergent light. I'm plotting emergent light. Here this is Ex. Here it is Ey. Okay. So what this light will be? This light will be same. This is tan theta. So what is this? This is emergent light. This is emergent light. And what type of light is this? Your electric vector, it will be like this. Okay, it will be like this. This will be the electric vector. Okay, now you are going to call this is the emergent electric vector E. So this is the same vector what was incident. What is this light? This is plane polarized light. This is the electric vector. This electric vector light was traveling like this. Electric vector is like this. So emergent light is this. So what is this light? Plane polarized light. And this is the same plane polarized light. Incident plane polarized light. Electric vector of incident plane polarized light was making an angle theta with the x-axis. Here in the emergent light, this is also plane polarized light, and electric vector is making the same angle theta. Okay? It is making the same angle theta. Beta. It is making the same angle theta here. This is theta with the x-axis. With the x-axis here. So you can write in this case, we will get same plane polarized light. In this case, we will get same plane polarized light. Same plane polarized light on the emergent side. We will get same plane polarized light on the emergent side. That is plane of vibration. That is plane of vibration of incident light. That is plane of vibration of incident light and emergent light. That is plane of vibration of incident light and emergent light. And emergent light is same. And emergent light is same. Is same. Okay? So that is same. So this is case 1. So here, whatever light is incident, same light you're getting on the emergent side. So look, this is emergent light. Same was incident light. But now suppose you choose the thickness in such a way that phase difference between O ray and E ray is pi, 2 pi, 3 pi, 5 pi, like this integer multiple of pi. So case 2, beta. Case 2. So if thickness is such that the phase difference between O ray and E ray is pi, 2 pi, sorry, pi, 3 pi, 7 pi, like this. Then what will be sine delta? Sine delta will be 0, so right hand side will remain 0. But cos delta this time, that will be -1. So if you place -1 here, then this term will become plus. And this will make the whole square again with plus sign here. So your equation will convert into Ex upon E naught x plus Ey upon E naught y whole square of this, and that is equal to 0. So what you are getting here, you will get Ey is equal to E naught y. ठीक है, this will be equal to minus E naught y divided by E naught x, and this is Ex minus tan theta Ex Ey. So what will be Ey? Ey will be tan of minus theta. ठीक है, I write like this, and this will be Ex. Slope is negative here. What is slope? Slope is negative here. So what will be the emergent light if you plot Ey and Ex? Then emergent light will be like this. ठीक है, it will be like this. This is Ex. This is Ey. And emergent light will be like this. This will be the emergent light. And this angle, this is the direction theta. So here what is happening, emergent light is, this is emergent light. This is emergent light. And this is PPL, plane polarized light. This is emergent light and plane polarized light. So in this case also emergent light is plane polarized light. But if you look here, its plane of vibration is rotated by an angle of 2 theta around the optic axis. This is the direction of optic axis. Remember this. This is also the direction of optic axis. And what was the incident light? Incident light was this. So incident light was like this. This is the direction of incident light. So this PPL, this was incident light. And this is emergent light. So emergent light is also PPL, plane polarized light, but its plane of vibration is rotated by 2 theta. ठीक है, but its plane of vibration is rotated by 2 theta. किसके चारों तरफ? Around the optic axis. It's not like this. I'm not saying it is rotated like this, no. Around the optic axis. Optic axis is in between. So it is rotated from here to here around the optic axis. So you can write here, in this case, emergent light, in this case, emergent light will be plane polarized light. In this case, emergent light will be plane polarized light, but its plane of vibration, but its plane of vibration is rotated by an angle 2 theta, but its plane of vibration is rotated by an angle of 2 theta around the optic axis. Around the optic axis is rotated by an angle of 2 theta around the optic axis. Full stop. Next line. This case is used to rotate. This case is used to rotate. This case is used to rotate the plane of vibration. This case is used to rotate the plane of vibration. Plane of vibration of a PPL, plane polarized light, of a PPL, of a PPL, PPL. Next line. Half wave plates are developed. Half wave plates are developed on the basis of this case. Half wave plates are developed on the basis of this case. Half wave plates are developed on the basis of this case. ठीक है बेटा, today I am stopping here. In the next class I will discuss, these are 7 cases. I have discussed 2 cases, 5 more cases are there, and you will find out 50% questions from the polarization. They can be solved on the basis of this analysis. If you understand this analysis, and on the basis of this you can explain half wave plate, you can explain quarter wave plate or other retarding plates. And most of the question they are based over this section. So please go through this. ठीक है ना? Before the next class, in the next class I will complete this analysis and I will explain you slowly and slowly how you use these cases for different analysis. ठीक है बेटा, please save all these slides I'm showing.
Sir,
Yes beta, please.
sir, if delta is 0, then there will be no lagging behind of O ray and E ray, sir.
Yes beta, there is no lagging between O ray and E ray. That is 2 pi. There will be a lagging, but that phase may be 0. ठीक है, 0 will be when thickness is 0. ठीक है ना, when thickness is 0. ठीक है, अगर if you are choosing t is 0, it may be 2 pi. ठीक है, it may be 2 pi very easily. So 2 pi means phase, there was a part difference, there was a phase difference, lagging was there, but that lagging was such that corresponding to it phase difference is 2 pi. So lagging is there, but you're creating a phase difference of 2 pi. Is it clear what I'm saying?
Sir, phase difference to I can't understand, sir.
Phase difference. Okay, I will explain you in the next class. When I will start, I will try to explain you how this phase difference is introduced between between X component and Y component. I will further try to explain more how this phase difference is coming into the picture. Actually, with omega t here at this point, Z is 0. So your equation is E naught sine omega t. But when it will propagate in this direction, suppose it has traveled a distance of t here. So here at this point, your equation will become sine omega t minus kt. Minus kt. So this part will also be there. I will explain you how that phase difference delta is coming. Then you can understand in a much better way. So I will start from there in the next class. So today,
Okay, sir.
please save all these slides and please go through this, how this phase is coming. I will further explain. So this is the first one. Second, third, fourth, fifth, 6 and 7. Last one, beta. Okay, beta. Thank you very much.
Thank you, sir.
Welcome, beta.